Okay, Year 10. Today we're going to look at making more salts. You can find this on the Caboodle digital textbook from pages 94 to 95, or you can search making salts on BBC Bitesize. So there's all sorts of different salts that are used throughout the world for various different purposes. You can see here there's some ammonium nitrate that's made in the Ukraine. Ammonium nitrate is a fantastic fertilizer. Without ammonium nitrate, we couldn't sustain the world's population. Calcium carbonate, as shown here, being ejected from this bucket underneath the helicopter, is used to neutralize soils, or in this case, to neutralize acidic lakes. This is a lake in Sweden that has been subjected to a large amount of acid rain. So this helicopter here is dumping in calcium carbonate, metal carbonate base to neutralize the acidity of the lake here. Okay, to get us warmed up for learning, I've put a little very crudely drawn equation here showcasing the different atoms and the different colours. We looked at this very much in the previous video lesson, and we're thinking about how else we can make salts. So as a little starter, I'd like you to pause the video in a moment, describe what the above diagram is showing you about neutralization, how is the water formed and how is the salt formed. Just written out in words very simply. Pause the video now please and we'll run through the answer in a moment. Okay, hopefully you've had a chance to think about this, Year 10. Here we have a sodium ion. The sodium ion, here shown in orange, is going to react with the chloride ion, forming sodium chloride. That's this latter part here in terms of how is the salt formed. The water over here, H2O, is made by a hydroxide ion here, OH-, reacting with a hydrogen ion, H+, to form water. This is neutralization because the water is pH 7 and the salt is also neutral as well. This whole reaction here is a neutralization reaction. The things on the right here are neither acidic nor are they alkaline. Over here we've got an alkaline in terms of sodium hydroxide, and we've got an acid in terms of hydrogen chloride or hydrochloric acid. Okay, we need to know the formula for various different acids. So down the left-hand side of this particular table, we have hydrochloric acid, sulfuric acid, nitric acid, and phosphoric acid. We went through these acid formula in the last video lesson. However, I am making you aware of them again because they're so important and crop up a lot. So hydrochloric acid is HCl, sulfuric acid is H2SO4, nitric acid is HNO3, phosphoric acid is H3PO4. In terms of hydrochloric acid, the salt anion, the negatively charged ion, is called a chloride and has the formula Cl-. A sulfate ion has the formula SO4 2-, and a nitrate ion has the formula NO3-. Whereas finally a phosphate ion has the formula of PO4 3-. You need to know these ions, guys. In a moment, please pause the video, copy out this table into your exercise book and do your best to learn these formula. If you already know them, you can tick it off here in terms of this right-hand column. If not, you need to make a little flashcard or do your best to learn this table off by heart. Please pause the video and do that now. Okay, Year 10. Last time we looked at how else we can make various different salts, and we looked at various different general rules to make different salts. So the first equation that we looked at way back when, several lessons ago, was acid plus metal makes a salt and hydrogen. This is not a reaction involving a base, but acids in general react with reactive enough metals to form a salt and a hydrogen. The next two are very, very similar. An acid and a metal hydroxide makes a salt and water. and an acid plus a metal oxide makes a salt and water. In both of these cases, the products are a salt and water, a salt and water. These two substances here are classed as bases, metal hydroxides and metal oxides. Metal hydroxides are a special class of base known as alkalis because they dissolve in water. Metal oxides tend to be insoluble, so are described as insoluble bases. And that's the only difference between these two substances. They both react with acids, but metal hydroxides dissolve, whereas metal oxides do not. So this is known as a special sort of base, an alkali, whereas this is known as just a base on its own because it doesn't dissolve in water. The other one that we finished on last video lesson looking at was an acid plus a metal carbonate. Now metal carbonates, as well as forming a salt and water, just as the other two bases do, they also form carbon dioxide. So whenever you take an acid and a metal, you form a salt, water and carbon dioxide. I've also reminded you of what you wrote down on the previous screen, the previous slide, about nitric acid forming nitrate salts, sulfuric acid forming sulfate salts, and phosphoric acid forming phosphate salts. Finally, hydrochloric acid forming chloride salts. There are some word equations underneath here. This is a nice and simple, straightforward little activity, a foundation level activity. Please pause the video and have a go at the word equations in the bottom orange box. Okay, let's run through the answers. I haven't color-coded them here in terms of the previous lesson, but there we are. Hopefully we're up to speed with that now. When I take magnesium, which is a metal, and react it with hydrochloric acid, which is obviously an acid, I make a salt, and the salt I make is magnesium chloride. I also form hydrogen because it falls into this first general equation, this first general rule. The second example, we've got sodium hydroxide, which is a metal hydroxide, reacting with sulfuric acid. So again, I make a salt, sodium sulfate. However, this falls into the second equation here. An acid plus a metal hydroxide makes a salt and water. So the salt is sodium sulfate, and obviously we form water as well. The third example fits into the last general rule in terms of we have here a metal carbonate. Potassium carbonate plus nitric acid makes potassium nitrate, that's our salt here, water and carbon dioxide. And then lastly, this is the last example here, this third example up here in terms of the general rule, we have a metal oxide reacting with an acid. So we have copper oxide plus phosphoric acid, the salt is copper phosphate and water. Remember, whatever you have on the left hand side in terms of elements must appear on the right hand side here. All we're doing is rearranging those elements. We can't destroy or create matter, we can only change it into a different form. So I showed you this equation at the start, this little visual way of representing this reaction between sodium hydroxide and hydrochloric acid to form sodium chloride and water. I'd like you to give it a go drawing a diagram in this particular style, right, for this particular reaction. So the reaction between magnesium carbonate and sulfuric acid forming magnesium sulfate, water and carbon dioxide. Pause the video to draw a diagram to show what happens, and we'll run through the answer shortly. Okay, so I've done this in two stages. Let's just focus on the reactants here, magnesium carbonate and sulfuric acid. This is what I've drawn for magnesium carbonate. This is what I've drawn for sulfuric acid. Magnesium carbonate is MgCO3, 3 oxygens, 1 carbon, 1 magnesium. Sulfuric acid is H2SO4. In terms of the products then, we form magnesium sulfate, water and carbon dioxide. And hopefully your diagrams look something similar to this. You've got magnesium sulfate, MgSO4, water, which is obviously H2O, and carbon dioxide CO2. Well done if you got that right. Let's look at some exam questions then. Here's a real AQA exam question. We're going to go through this slowly and steadily. Again, once I've run through the question, please pause the video and give this a go yourself. When a metal carbonate reacts with an acid, a salt, carbon dioxide and water are produced. So it's telling you that you've got a metal carbonate and you're reacting with some kind of acid, you form a salt, carbon dioxide and water. The first part of the question says, describe how you would test for carbon dioxide gas. It's worth 2 marks, it's asking for the test, and then it's asking for the result. Well, I'd like you to pause the video, have a go at part A. I'll show you part B in a moment, and then we'll run through the answers. Hopefully you've had the chance to have a go at part A. This is now part B. Describe how to make pure dry crystals of magnesium chloride from magnesium carbonate and a dilute acid. In your method, you should name the apparatus and reagents, that's the same as reactants, you plan to use. And this is worth a whopping 6 marks. Now, I know that many of you are daunted by these sorts of questions, but they are going to crop up and you do need to be prepared for them. What I'd encourage you to do is think carefully about how you can write this down logically in a sequence. Remember, on exam questions, you don't need to write in full sentences. All we're bothered about is the science valid? Is it correct? You're making magnesium chloride, that is your product, from magnesium carbonate and a dilute acid. You're going to need to state the reactants you're going to use. What acid are you going to use? What apparatus? Step-by-step method. And in a moment, we'll come back and we'll run through the answers. So please pause the video to give part B a go now. Okay, well done for attempting that. For part A, the test for carbon dioxide is lime water. You could also say calcium hydroxide solution. So if you've mentioned lime water as part of the test, give yourself a mark. The result of using lime water is that lime water will turn cloudy or milky when carbon dioxide is added. You must link your result to lime water. That's worth 1 mark as well. Part B. 6-mark questions are always marked in levels. And you'll remember when we've gone through these as part of end of unit tests and things, that I will write in the margin L1, L2 or L3. Let's look at what each level states and what it's worth. Let's start at the top with level 3. The method would lead to the production of a valid outcome. In other words, you've got magnesium chloride as your salt formed. All steps are identified, so you're saying what each step will be and logically sequenced. So it makes sense in terms of the order in which you're doing things. And that's worth 5 to 6 marks. For level 2, the method would not necessarily lead to a valid outcome. Most steps are identified, i.e. not every single one, but the method is not fully logically sequenced. So it's not a step-by-step method. It's not clear what goes what and in what goes where in an order that makes sense. And that's worth 3 to 4 marks. Level 1, the method would not lead to a valid outcome. Some relevant steps are identified, but links are not made clear. 1 to 2 marks. All 6-mark questions are marked in exactly the same way. Let's take a look at some indicative content then. So you'll recall that when I taught this to you last time, and a video will be coming up on this showing you the experiment, there are several stages to this. There's the reaction, there is filtration, evaporation and drying. So in terms of the reaction, you'd have to use hydrochloric acid. You're wanting to form magnesium chloride. It doesn't tell you the acid in the exam question, so you need to select the fact that it's hydrochloric acid. Any other acid would not lead to a valid outcome. In other words, you must have hydrochloric acid written down to get all 6 marks. You need to place that acid in a suitable container. So I would put, place hydrochloric acid in a beaker. Then you would need to add a spatula of magnesium carbonate. It told you that magnesium carbonate was your base in the question. You'd need to stir it, continuing to add magnesium carbonate until it is in excess. And you'll recall that from the video lesson last time I made a big deal of the fact that your base would need to be in excess to make sure that all of the acid reacted. When solid remains or no more effervescence occurs, effervescence is a posh word for fizzing, then you know that the reaction is in excess. You don't need to state all of these steps. You could simply say, use hydrochloric acid in a beaker, add magnesium carbonate and stir until the solid remains left over, it's in excess. In terms of the filtration then, you'd need to filter to remove the excess magnesium carbonate. You'd need to use a filter paper and a funnel, and you need to pour the solution into some kind of evaporating dish. Because guess what's coming up? Evaporation and crystallization. You need to evaporate the water until it crystallizes. You could use an electric heater or you could use a water bath. In the video that I showed you, we talked about using a water bath. You'd need to leave it to cool so that crystals form. You could pour off the excess water or you could filter it, and you'd need to dry it because it did ask for clean, dry crystals. So you could dry the crystals in a cool oven or you could sort of blot them with filter paper. Well done if you got most of those things correct. You'd need to state that it's hydrochloric acid to get all 6 marks, and you'd need to have most of these things here to make sure that it's clear in a logical sequence for 5 to 6 marks. Well done for giving it a go. Let's have a look at another exam question. Here's another exam question then. A student plans a method to prepare pure crystals of copper sulfate. The student's method is add 1 spatula of calcium carbonate to dilute hydrochloric acid in a beaker. It then says when the fizzing stops, heat the solution with a Bunsen burner until all the liquid is gone. The method contains several errors and does not produce copper sulfate crystals. Explain the improvements the student should make to the method so that pure dry crystals of copper sulfate are produced. Couple of things to be aware here. It's marked exactly in the same way as the other 6-mark question, because this is a 6-mark question in those 3 levels that we've discussed. However, the focus of the question is slightly different because it's saying that it has several errors and it wouldn't produce copper sulfate. So in your answer, you're going to need to say what the student would need to do to get copper sulfate and what the other errors are to make it sure that it's a valid method to produce that copper sulfate. Please pause the video now and have a go at this 6-mark question. Remember, you don't need to write in full sentences. Bullet points will do. Okay, welcome back. Just to remind you, each of these 6-mark questions are marked in these same levels. So for level 3, you've got relevant points with reasons and causes are identified, giving a detailed, and here we are, there's that word again, logically linked to form a clear account. So it's got to be logically sequenced, step by step. That's worth 5 to 6 marks. For level 2, you'd still have relevant points, but the account isn't fully clear because whilst you've attempted logical linking between those various points, it isn't fully clear in terms of getting to those copper sulfate crystals. That's 3 to 4 marks. Level 1, points are identified and stated simply, but their relevance is not clear. It's not clear why those points are important, why the points you've identified are important. And there's no attempt at logically linking the points. That's worth 1 to 2 marks. Let's look at some indicative content. What could you write to get all 6 marks? You'd need to say that you would use sulfuric acid. After all, you're forming copper sulfate, not copper chloride. So you don't want to use hydrochloric acid. The student incorrectly identified hydrochloric acid. Or you could simply say that sulfuric acid is needed. You'd need to use copper carbonate or copper oxide, not calcium carbonate, as identified in the method. Copper carbonate or copper oxide will produce copper sulfate with sulfuric acid. Calcium carbonate with hydrochloric acid would form calcium chloride. Or of course you could say simply as with above, copper carbonate or copper oxide is needed. You'd need to add that solid, add that base, whether it's copper carbonate or copper oxide, until the solid remains. Or you could say until it's in excess, or until no more reacts or no more dissolves. This is to ensure that all of the acid has reacted. You'd then filter it. That's to remove the excess or the unreacted solid. You could say the unreacted copper carbonate, the unreacted copper oxide. Finally, you'd heat it gently or partially evaporate off the water or leave until it crystallizes. Here's the important part, guys. For level 3, you have to identify the correct chemicals. That is to say sulfuric acid and copper carbonate or copper oxide. Thank you ever so much for listening and paying attention, and I'll see you next time.